Welcome to section 8.2 Array Lists. This lesson is all about leveling up from basic arrays to a more flexible, powerful data structure that is part of Java's collections framework, the array list. By the end of this lesson, you'll be able to create and use an array list, add, remove, and get elements using built-in methods, loop through an array list using for each iterator and list iterator, and use wrapper classes to store primitive data types with auto-boxing. In real life, objects come in groups: cars in a parking lot, accounts in a bank, students in a class. In Java, we deal with groups of data the same way, and that's where collections come in. Collections let you manage groups of data, especially objects. One of the simplest and most commonly used collection types in Java is the array list. It's like an array, but with superpowers. Say you're managing a list of students in Java Programming 101. You could use a basic array like this: string array, students, assign Mary, Sue, Harry, Rick, Cindy, Bob. But then what if Mike and Larry join and Sue drops out? Now you're rewriting and resizing manually. That's not ideal. That's one of the biggest downsides of arrays. They have a fixed size. Once you set it, it can't grow or shrink. You're stuck managing changes yourself. Enter the array list. This is a class in the Java standard library that solves that exact problem. It's like a resizable array that grows and shrinks as needed, stores objects, not primitives, has built-in methods for adding, removing, and accessing elements. What can you store in an array list? Any object, including ones you create yourself, like string, integer, person, car. The catch is no primitive types like int or double, but don't worry, we'll fix it later using wrapper classes. To use an array list, you first import it. Import java.util.arraylist. Then declare and instantiate ArrayList string states new ArrayList. The string part is the type parameter. It locks the list to only store string objects. Now, how do you actually work with one? Not with square brackets. Use methods like add, remove, get, index of, set, size. All of this make array lists way more powerful and convenient than arrays. When you declare an array list, use the diamond operator to indicate the object type. In the slide example, there are a number of methods to add data to the array list. This example uses the add method to add several string objects to the list. The add, with two parameters, index and element, method inserts an element at a specified location. Using the remove method, you can delete an element by passing the index or by passing an item to be deleted. Remove 0 removes the first element at index 0, in this case, Jenny. Remove names.size -1 removes the last element, which would be Jose. Remove Gustav removes an element that matches a specific value. You can pass the array list to system.out.println, so the resulting output is Prashant and Alisa. Note, removing an item does not leave a gap in the array. The array size is reduced. Key thing to remember: when you remove an item, the list shrinks and shifts elements. No gaps are left behind. In exercise 1, part 1, create a new project and add ArrayList x1.java. Modify the program to create an array list of string named students. Add Amy, Bob, Cindy, and David. Print all elements and display the list size. In exercise 1, part 2, add Nick and Mike at index 0 and 1. Remove the student at index 3. Print the updated list and its size again. You're seeing how dynamic the array list really is. Now let's talk about traversing an array list. There are three main ways: for each loop, iterator, and list iterator. Each has its use case. Start with the for each loop. Easy and clean. This is great for reading data, not so great if you need to remove items while looping. In the exercise, try it in ArrayList traversal Java. ArrayList string names new ArrayList, names.add Tom, names.add Mike, names.add Matt, names.add Nike. For string I in names, system.out.println name is I. For more control, use an iterator. You import java.util.iterator, then create iterator object, iterator of string, iterator assign names.iterator, while iterator.hasNext, print name is iterator.next. You can also safely remove items during iteration. To use an iterator to cycle through the contents of an array list, follow these steps. Call the collections iterator method, set up a loop that makes a call to hasNext, and have the loop iterate as long as hasNext returns true. Within the loop, obtain each element by calling next. Want to go both directions? Then use list iterator. Using list iterator, use next to traverse forwards, use previous to traverse backwards. This is really helpful when editing or reviewing from both ends. Now back to a key limitation. ArrayList only stores subjects. So how do you store numbers? The answer is use wrapper classes. Java provides these wrapper classes to convert primitives into objects. Here is the list of primitive data types and their corresponding wrapper classes. Java has a feature of automatic conversion of primitive data types to their wrapper classes and vice versa. This is called autoboxing and unboxing. Autoboxing is automatic conversion from primitive to object, like double, capital D, score, assign 18.58. Unboxing is the reverse. Double, lowercase d, goal, assign score. Java does this behind the scenes, so you don't have to. The core example demonstrates how you can populate array lists with primitive data by using autoboxing and unboxing. Autoboxing, int is converted to an integer, capital I, and is added to array list without explicitly invoking the wrapper class integer. Unboxing, the integer object is converted to the primitive int without invoking any method to do the conversion. In exercise 2, add ArrayList x2.java to your project. Use an ArrayList integer to store a list of numbers, display them using an iterator, remove all even numbers, display the updated list. This is real-world list manipulation in action. To summarize, ArrayList is more powerful than arrays. It grows and shrinks dynamically. Use add, remove, get, size, and set, and more. Loop through for each iterator or list iterator. Use wrapper classes to work with primitive data types. Let Java handle conversions using autoboxing and unboxing.